My name is Lindsey Malcom-Piqueux, and I'm the Assistant Vice President for Diversity, Equity, Inclusion, and Assessment at Caltech, where I also serve as the Chief Institutional Research Officer. In this role, I develop and implement research-informed, metrics-driven institutional efforts to ensure that Caltech is a diverse, equitable, and inclusive environment for all community members. I also oversee all areas of institutional research in support of Caltech's planning and decision-making processes. My presentation today focuses on approaches to supporting diversity, equity, and inclusion within STEM fields. I'm going to talk to you about some of the research-based approaches that Caltech and other institutions like Caltech employ in order to advance the goals of diversity, equity, and inclusion within STEM. But before diving into those specific examples, I want to provide a little bit more context for the challenges that we face around broadening participation in STEM fields. Right now, we know that the rich diversity of our world is not reflected in STEM fields. It's not reflected in the STEM workforce, nor among STEM degree earners. And this is a problem. Here in the US, this graph shows the demographic breakdown by race and gender of the United States working age population compared to the demographic breakdown of the US science and engineering workforce. And here, this graph shows that there are clear patterns of gender and racial underrepresentation. Women of almost every single race are highly underrepresented among the STEM science and engineering workforce, whereas men of color are also severely underrepresented within this workforce. This challenge is not unique to the United States. If you look at some of the data that was compiled by UNESCO in exploration of gender equity to research careers, you can see that the proportion of researchers that are women across the world fall far below their representation within the population. And of course, the challenges that we face with the STEM workforce originate from gendered and racialized patterns of degree attainment within STEM fields. It's been over 40 years that women have reached gender parity in earning bachelor's degrees from US institutions in all fields. But if you look at STEM, you can see that in the sciences, technology, engineering, and mathematics related fields, women continue to be underrepresented among bachelor's degree earners, despite the fact that they make up more than half for all fields. And if you look at specific STEM disciplines like physics, in this case, the severity of the underrepresentation is even greater. If we look at data broken down by race and gender, we can see that these patterns persist. Here, this graph shows the proportion of bachelor's degrees conferred by US institutions earned by racially minoritized groups by field and gender. So the orange bar shows the share of all degrees in the indicated field earned by Black, Latinx, and Indigenous men in the US, and the navy blue bar shows the proportion of degrees in these fields earned by racially minoritized women in the US. And you can see that for women, right now, underrepresented minority women earn 14.2% of bachelor's degrees in all fields. But if you look at their representation in the biological sciences, in the physical sciences, in computer science, math, and statistics, as well as engineering, we see that they fall far below that mark. Similarly, Black, Latinx, and Indigenous men earn a smaller proportion of degrees in the biological sciences, in the physical sciences, math and statistics compared to the proportion that they earn in all fields. These patterns persist if we look at PhDs. And here you can see the severity of the underrepresentation is even greater. So why does this matter? Well, it matters for many reasons. The one that pops up in my mind first and foremost is it's a question of justice. Is it fair that certain demographic groups don't enjoy equitable access to STEM careers and STEM degrees? Is there something that needs to be done in order to rectify this injustice? It also matters because a great deal of research has demonstrated how diversity among research teams, within labs, and within the classroom can lead to greater innovation and greater learning. And additionally, we know that the underrepresentation of women and racially minoritized populations in STEM fields matter because of the impacts of science on society. Scientists are often the ones who determine which questions are going to be asked and investigated. And they also shape the nature of the solutions to many of the problems that we face as a society. One need only look at the failures in certain AI solutions, certain algorithms, search engine algorithms that actually produce racialized and discriminatory results. And oftentimes, one wonders if that is linked to the lack of diversity around the table among those who are developing these technologies. Well, what do we do about it? So we know that it matters. What do we do? Well, in order to understand what to do in order to fix these persistent inequities that exist, we need to understand the root causes. And the root causes require us to reflect back on our history, which can often be very, very difficult. We know that much of our society, in the US specifically, but in other societies across the globe, are predicated upon systems of oppression: sexism, patriarchy, racism and white supremacy, classism, ableism. And these systems of oppression ensured that opportunity was hoarded among the privileged and it was withheld among those who were not privileged. And these systems of oppression resulted in the systemic and intentional exclusion and denial of opportunity based on identity, like gender, race, ethnicity, social class, ability status, as well as many other aspects of identity. And the systems of oppression and the practices of exclusion contribute to the culture, mindsets, and practices that persist today within our broader society, within the STEM disciplines, within our higher education institutions, within our departments, our classrooms, our labs, that often determine who is seen as a valid learner and doer of science. One thing to understand as well, in addition to the root causes of the patterns of inequity that we observe, is to understand exactly what we mean by these terms. What are we trying to achieve? It's really critical that everyone has a shared understanding in order to ensure that we can work together to achieve these goals. Diversity, I'm sure everyone is familiar with what that means. With diversity, the emphasis is on access and representation within the institution, within the community, within the discipline, within the research facility. Equity, on the other hand, is different from diversity. With equity, the emphasis is on achieving parity in outcomes and opportunities. With equity, the emphasis is on fairness. And in order to be fair, there also needs to be a consciousness of how social location, for example, your gender identity, racial identity, socioeconomic status, ability status, and many others, can affect the opportunities that are available to an individual. Who has the opportunity to pursue science and math during their educational journey? That is structured by many of the broader patterns of inequality that exist within our society. And then lastly, inclusion is unique and different from diversity and equity. Inclusion emphasizes how students, in my case, that's what I think about, from historically excluded and marginalized groups experience an institution or a department or a classroom, how they are valued and how they are welcomed into that space. So one of the things that is clear from the research literature on how we can broaden participation in STEM fields is that cultivating and supporting diversity requires attention to equity and inclusion. We can't just bring more people in if we're not also thinking about what type of experiences we're creating for them once they're at our institutions. And there's been decades of research done in order to understand what are some of the most promising approaches to promoting equity and inclusion in STEM. I've categorized these approaches into 4 primary areas. 1, looking at practitioner action. So what can an individual staff or faculty member do? Targeted interventions, departmental and institutional reforms, and systemic change efforts. And so I'm going to describe what I mean by each of these approaches, and then I want to provide some concrete examples of what that might look like in practice. So practitioner action focuses on the efforts of individual faculty members, administrators, or staff who, upon their own initiative, driven by their own values, engage in intentional action in order to support individuals from groups that have been historically excluded and marginalized. In our case, we're talking about from the sciences, but really this is within higher education more broadly. So as I said, the actions are driven by the values of the practitioner often, and a lot of the action actually happens on an informal basis. So it's not tied to any formal program. It's something that a practitioner does because they recognize the importance of diversity, equity, and inclusion, and they want to live out those values as well as just espousing them. The challenge with this is that oftentimes these efforts are reliant on individuals. And if an individual leaves an institution, the practices might be discontinued and any progress made may disappear. So one primary form of practitioner action that research has shown is particularly effective in promoting equity and inclusion in STEM is that of institutional agents. So what is an institutional agent? Well, institutional agents are practitioners, faculty members, staff, administrators, people in industry who hold a position of power and authority over resources related to a student's education. It could be knowledge, experience, commitment, social networks, professional networks. And institutional agents use the status that they possess in order to provide opportunities for students, especially those from populations which have been historically marginalized and excluded from the sciences. The type of support that institutional agents may offer are quite broad and come in many different forms. Sometimes institutional agents provide direct support in the form of mentoring, guidance, or resources to advance students' opportunities to succeed. Sometimes it's system linkage and network support, where they build networks to support equity and inclusion, both internal to their institution as well as external communities within their discipline or field more broadly. They're system developers, those who try to create programs, policies, and structures in order to support equity and inclusion within STEM. And then there is integrative support, where an institutional agent will try to facilitate student access to professional communities and standards, really showing them the ropes in terms of socializing them to the STEM discipline. So, and not every practitioner is an institutional agent. In order to be an institutional agent, a faculty member has to be willing to use their power in order to advance the ideals of equity and inclusion, and use their power to confer benefits onto students directly. But even in your everyday practices, those who act as mentors or interact with historically underrepresented populations in STEM can do a great deal to make a difference and make a learning environment more equitable and inclusive. So you may have heard of microaggressions. Oftentimes those who have been historically excluded within a higher education environment or departmental environment might experience oftentimes unintentional, sometimes intentional exchanges that communicate hostile slights or insults and result in harmful or unpleasant psychological influence on an individual or group. And oftentimes that individual or group, as I said, is one who's been historically marginalized. Similarly, micro invalidations often happen. And these are what is part and parcel of what's been called sometimes a chilly climate within certain STEM departments. Well, as an individual practitioner within higher education, or if you're acting as a mentor to diverse student or group of students within a STEM setting, there are things that you can do in order to provide additional support to these students. Micro affirmations, for example, are a form of relational practice. So how you interact with an individual who's from a minoritized population or historically excluded population, where you try to counteract the effects of microaggressions and micro invalidations. You are intentional in conveying that this person belongs, that you support this person, that you appreciate them, and that you believe that they can succeed within their environment. So this is yet another kind of informal and very small way that you can ensure that you're helping to make an environment more inclusive. There are also targeted interventions that exist, which are smaller scale programs and activities that seek to positively influence the experiences of historically excluded groups, in this case within STEM. And oftentimes these programs use evidence-based practices that emerge from the higher education research literature or STEM educational research literature in order to eliminate barriers that stand in the way of participation within STEM fields. And so they are intended to provide support to students, and oftentimes they require a lot of resources and require a lot of time on the part of staff, faculty, and institutions. And so sometimes they're difficult to implement, but we know that there are a number of types of targeted interventions that are particularly effective in promoting equity and inclusion in STEM fields. At Caltech, we use a summer bridge program model to enhance the pre-matriculation experiences of incoming first-year students, as well as now incoming graduate students from historically underrepresented populations within STEM fields. And the purpose of these efforts is to help to familiarize students with the expectations of the institution, with the curriculum that will be offered at the institution, the degree program structure, research opportunities, as well as career opportunities within STEM fields. And the purpose is to ensure that students receive instrumental support, that they receive psychosocial support, as well as engender positive relationships with other students and other faculty on campus. Another approach that is used in order to support equity and inclusion in STEM fields is efforts to reform departments and institutions. And so these are when an entire department or entire institution engages in an effort in order to change the way that they do things, their practices, their policies, and routines pertaining to students and pertaining to historically underrepresented student populations in particular. Oftentimes, these reforms will aim to impact all students, but oftentimes the greater positive effect is on historically underrepresented students. Typically, such reform efforts focus on core aspects of the student experience, for example, advising, the curriculum, teaching practices. And one of the things that is notable about such reform efforts is that it requires the institution and the faculty to buy in. It requires institutional support in the form of resources. It may come in the form of time. It may come in the form of material support. And it also involves faculty training and professional development. So one example of such an effort at Caltech was the Inclusive Caltech Core project, which sought to bring together faculty who teach in our first year undergraduate core curriculum to ensure that they can form a community of practice and make their teaching more inclusive. And so within this effort, we try to support faculty in their adoption of evidence-based instructional strategies in order to improve student learning and to increase students' academic engagement. And so there are many examples that emerge from the research literature about inclusive teaching practices. And there has been a great deal of empirical evidence supporting the effectiveness of these practices. One of the other things that's also noteworthy about inclusive teaching and what we often discuss within the Inclusive Caltech Core was the need to integrate socially and culturally relevant examples into the classroom and into the content that was being delivered, as well as implementing and using different types of assessments for student learning, including community and project-based learning. So the reason why this was a promising approach to supporting equity and inclusion in STEM is because these teaching practices help students to see the relevance of STEM fields to their own values that they possess, to their own communities, and they are more likely to be able to successfully integrate their science identity into their core identity as an individual. Institutional reform efforts also seek to ensure that everyone kind of changes their mindset about equity and inclusion, to ensure that they come to see it as everyone's responsibility, a shared responsibility, that they come to see it as being core to the performance of the institution instead of at the peripheral, and to ensure that it's very clear to the campus community that diversity, equity, and inclusion is a value that is of high priority at the institution. And the last type of approach to supporting equity and inclusion that I want to discuss are systemic change efforts. So recall back to the beginning of the presentation where I talked about the need to kind of get to the root or understand the root causes of the challenges that we face related to equity within STEM. And honestly, because the root causes of the challenges that we face are so complex and so deeply entrenched in history and society, it's really important that we seek to change all aspects of the system in order to create equity and inclusion within STEM. And so systemic change efforts, many institutions have, or institutional systems have sought to undergo them. These are large-scale efforts that, as I said, seek to address the root causes of the persistent underrepresentation. They engage multiple stakeholders, including institutions, but also disciplinary societies, higher ed association, businesses, industry, the government, in order to bring about cultural change, where there's a shift in the norms or the logics that drive the work within a discipline. So a change in the values and the assumptions and the beliefs that govern how things are done and how the STEM disciplines are experienced by populations who are historically excluded. Changing the culture and changing the climate is very challenging. And in fact, there is no comprehensive how-to out there. It's something that is organic, but we do know some things about change efforts and what helps to support those change efforts and what can derail them. So some of the first principles of cultural change as it relates to increasing diversity, equity, and inclusion in STEM fields. First, we have to acknowledge that STEM disciplines, despite the value that we place on objectivity, are not value neutral. They're human endeavors and human enterprises. And the biases and assumptions that we bring that are born out of the societies in which we're raised can have a significantly negative impact on populations who are historically underrepresented and historically marginalized. One only look at some of the research that's been done on faculty biases, where there was an experiment that was done where faculty were evaluating postdocs and they simply changed the names on the top of the CV. The rest of the CV was exactly the same. And there's empirical evidence that there were gender and racial biases that disadvantaged women and disadvantaged racially minoritized populations. So it's really critical that as we embark upon cultural change in order to support equity and inclusion within STEM, we acknowledge and reckon with the history of exclusion and discrimination that are rampant throughout our disciplines and throughout our institutions. We also have to acknowledge the fact that sexism and racism persist today. They are not, unfortunately, instruments of the past. They impact the everyday reality of many populations who have been historically excluded from STEM fields. And these, continue to exist within our disciplines, within our departments, and within our institutions. And so oftentimes, a faculty member or a higher education practitioner will ask, well, what can I do? One of the places that we can start is kind of taking a look in the mirror and critically examining our own personal beliefs about who is a valid learner and doer of science, our own biases that we carry, and we all have them, and the stereotypes that may inadvertently shape how we interact with students and who we believe has the capacity to succeed. Additionally, one of the things that we have to do in order to change the culture is to change what is valued and what is rewarded. If diversity, equity, and inclusion is an institutional value and priority, then we need to reward those faculty members, those researchers who go the extra mile in order to promote these values in their everyday practice. So in conclusion, creating equity and inclusion in STEM is a complex endeavor, and it requires sustained action at multiple levels. There is no quick fix. The roots, of this problem run deep, and for that reason, it's going to take action at every single layer of our higher education system, of our scientific and research enterprise, in order to move the needle on these issues. And so I thank you so much for your attention. And I look forward to interacting with you and answering your questions later on in the conference.